No matter how large or small your tree fruit farm may be, the need to spray chemical pesticide products accurately and effectively is critical to your success. That's why proper calibration is essential for keeping your spray equipment operating at peak performance. When sprayers are used without regular calibration, you risk over or under applying chemical pesticide products, which can lead to problems such as low yields, damaged foliage, soil contamination, and even pesticide-resistant insects and weeds, not to mention the financial cost of wasted pesticide products. With this simple worksheet, you'll be able to see to it that your Air Blast sprayer is functioning as it should, and in a cost-effective manner. These are also valuable records that can be used each season to track expenses as well as the effectiveness of a given sprayer or application program. Like most calibration procedures, we'll measure a small sample in order to determine the total output over your entire farm acreage. First, let's take note of the equipment being calibrated. The first part of the worksheet gathers the basic identification information, along with the date, operator, location, and equipment being used for the calibration. Take note of the tractor's details, such as the tractor make and model, tractor tires brand, the gear it's being driven in, as well as the RPM. Also, record the tractor tire size and height, from the ground to top of tire. And remember to record the sprayer make and model, tank size, and pump pressure. Because the calculations are based on a sample size plot of your fields, you'll be traveling a measured course, preferably a level, straight stretch. 200 feet is a recommended minimum distance for accurate calculations. The tractor should be pulling a clean sprayer tank, filled halfway to represent an average weight load. Measure the distance to be traveled. For this test, 264 feet, and the time to travel the course is then recorded, once down and once back. Record it twice, then average the 2 times in order to establish a standard time. If the first 2 measured times have more than a 10% differential, it may be necessary to repeat the timing tests. In this test, the time was 44.16 seconds for the first run and 42.03 seconds for the second run, for an average of 43.10 seconds. Next, we'll convert the recorded times into miles per hour and speed per minute as part of determining how many feet per minute are being covered and consequently how much product is being applied at each foot. Calculate the distance in feet multiplied by 60, then divide that number by the time in seconds multiplied by 88. This will give you your miles per hour number, 4.18. Then multiply the miles per hour by 88 to arrive at the feet per minute being covered by the tractor and sprayer. In this case, that comes to 368 feet per minute. In the orchard, you'll want to measure the width of the area of application. Be sure to take note of the tree height and width, as well as the block number and row width in feet. Here, the row width is 12 feet. If you'll be spraying alternative row centers, you'll want to measure the spray swath width. Then we take the total number of linear feet of row per acre, 43,560, and we'll divide that by the row or swath width measurement to calculate the footage being sprayed in each acre. This comes to 3,630 feet being sprayed in each acre. Next, divide the linear feet row per acre by the number of feet per minute that the tractor travels, based on the earlier time testing. This will determine the time being spent spraying each acre. For this situation, that figure is 9.86 minutes per acre. As part of the worksheet, you'll find this chart for recording the collected output of material over a measured time. Take note of the nozzle brand, tip size, and disc core number. Again, make sure that the sprayer tank has been cleaned and filled with clean water. No one wants to be exposed even to minimal amounts of pesticide product during testing. For 60 seconds, record in ounces the collected output for each individual spray head. If 60 seconds is too long for containing the output, cut the time in half and multiply appropriately to determine the output for the full test time. While collecting the water during the timed output, the presence of faulty tips or nozzles will be evident by the amount of fluid being released. If any individual head output indicates a deviation of more than 10% of the average output, it may be time to double-check the nozzle for damage or incorrect labeling and should be replaced. By adding the total output, you will be able to determine the total gallons per minute. In this test, that figure is 5.46 gallons. Multiply the gallons per minute by the minutes per acre figure calculated earlier to determine the total gallons per acre. Here, that total comes to 53.8 gallons per acre. As always, read the product label to understand the proper application rate for your given target. Knowing with certainty the amount of product being applied is an important tool for keeping your operation running productively and cost-effectively.